Starting now. FPM class 90 unlocked. Is voice clear? Fully audible? Voice clear? Fully audible? Clear and fully audible? Little fast? Okay, I'll start. See, first I'll do one thing. I'll fix the board up to where I can write. So that later there is no problem. Elastic curve, not doubt. I don't know why, I somehow hand touched it. Elastic curve. Elastic curve. Actually blue color. Okay. Now, first, make a note. Mic is off. Oh, sorry. I have not put the mic pin. Yes. See, thank you. Mic is on, but pin I have not put there. Okay, thank you. See. Still you can hear the voice, but now clear. Sometimes happens, some small mistake. After the class you come to know, then full class blurred voice. Now clear? Okay. I will not check the mobile today. Like I don't want like what happened yesterday. Okay. See, first make a note. Heading. Simply supported beams. Loading unsymmetrical. Loading unsymmetrical. Actually correct English word is not unsymmetrical. English word is asymmetrical. I do not want to use that word. Unsymmetrical is clear. Use unused. Known unknown. I feel unsymmetrical is a better word to understand. Here subject is important, not English. So that is not symmetric. Okay, now see, moment area method for unsymmetrical cantilever there is no problem. First of all, for cantilever, symmetry word only is not there. Why? The beam itself is unsymmetrical. Simply supported beam with symmetrical. Once again I will tell you, make a note. You should write a sketch. Symmetrical. BMD will be symmetrical. Right there. Symmetrical BMD. Elastic curve also symmetrical. Slope at center equal to 0. That is the point where deflection is maximum. If you want maximum deflection, you cannot find directly. Extend the tangent at center to support. Find, see, displacement of support with respect to tangent at center. See, how much is that one? Same is this one. Then, if any other point you want slope and deflection, you know procedure. Then, how to find slope at support? See, symmetrical. Theta A here, theta B here. Already told earlier. Then, apply the first theorem. See, first theorem connects the slope, where area of the BM comes. Second theorem, what? Gives you displacement, where moment of the area will come. Symmetrical case, theta A and theta B both are equal. Theta center is 0. So, apply a theorem from A to center, left end to center. Slope at left end minus slope at center 0 is area of this side BMD. Or you can do that side. You write A to C, or don't by heart C, B to C. Clear now? This already over earlier, plenty of problems. You should remember. This all clear? Now I am going to unsymmetrical. All this clear? Make a note again to understand. Symmetry means what happens. Okay, now come to unsymmetrical. See, random loading. I will put random loading. This is not a, see, random loading. Not symmetrical. BMD, see, error-berry. This is random BMD. Don't worry. Sir, how this comes? Random BMD. Do not worry about BMD. Now, see, one colored black I was having. I got it here. Now, I misplaced it. 1 minute. When you told, I see anything multiple. Yes. Okay, I got it. Now, what to do? This is a bending moment diagram. Not symmetrical. See, now, elastic curve. Elastic curve is always smooth. But now your theta A is not equal to theta B. Remember, your theta A is not equal to theta B. And slope theta at center is not equal to 0. Clear? See, this is not center. This is not center. If it is symmetrical, y max will be exactly center. If unsymmetrical, it will be somewhere else. So, your earlier property of slope at A equal to slope at B and slope at center equal to 0, where y is maximum, that is not valid. First make a note. Clear? First make a note. See, we will not do too many questions. Just one example here and finish. Why? Because if more complicated loading is there, you got Macaulay's method. Okay, now, first do one thing. I wrote something here. Correctly see what to do. Draw elastic curve. See, this is the blue color is elastic curve, I told you. This is tangent at A, this is tangent at B. Okay, now, this I will remove now. I want some space. Actually not difficult, very, very easy. It is not difficult. Understand everything. There is nothing difficult there. See, in the elastic curve, A, B, original position. After bending also, A will remain there only, B will remain there. Other points all will get shifted. So, blue color is the reference now. Okay, now, first do one thing. See, I wrote here, procedure. See, you should write irrespective of. Actually, irrespective is double R. Someone will tell, sir, what is English? Irrespective. That is to stress the point. Sometimes, when you someone is writing, giving food for you, you feel not required. What you tell? Little required. It was not required. Then they will tell little. Then you tell solpa. See, that way. So, little. No, you don't tell that. Little. Say, irrespective of whatever is or required, they may ask you only one, either theta A or theta B or deflection somewhere or slope somewhere or maximum theta or maximum y or many things can be asked. Irrespective of whatever is or required, always first find slope set support. Slope set support. For this question, our example, theta A, theta B. Don't by heart theta A, theta B, because I have seen some examination, they give question like this. For the beam shown in figure, this way, then those who by heart B gone case, theta A and theta C, that way. That's why slope at support as per our sketch, theta A, theta B. Okay, now, remember now, whatever they ask, you never see the question. Never see the question. They may ask anything. Your starting step is finding theta A, theta B. Without that, your further calculation will not come. That is, anything you require for this question, you should know slope set support. Fully clear? So you should write anything required. See, in the question, theta A, theta B may not be asked. They may ask you directly, what is deflection here? Even then, first find slope at support. Clear? Okay, now, little later, I will come this side. Draw, see, first I will one thing. This is continued. Little later, draw tangent to elastic curve at supports. Here, TA and TB. Mark the slopes with the direction. Theta A is like this, theta B is like this. Mark theta at support with the direction. That is here, draw TA, TB and theta A, theta B with direction. Then, what you do is, okay, now, right here, see, something, then this is the procedure. Come back once again here. I told you, whatever they want, first theta A, theta B required. See, note, class, I am dictating something now. Usually, earlier, what you used to do is, you consider Moore's first theorem from A to center, because center theta equal to 0. But here, where 0 theta is not known at present, we do not know where is the 0 slope. We do not know. Since we do not know where is 0 slope, we cannot use first theorem. If you use first theorem, what is theorem? Slope here minus slope somewhere. If that somewhere slope is 0, you get this slope. Why? That is 0. That somewhere slope 0, where? See, first theorem is theta minus theta. We always select the other point so that other theta is 0. This is not possible. Clear? This is not possible because we do not know where is 0 theta. Clear? Okay. Therefore, you need a new approach for moment area method. See, I want to waste time. Today and tomorrow, I want to finish this one. Because today is Thursday, yes. By tomorrow, this should be over. Next week, I am starting new chapter. Because too much of is not required. Basic concept required. So, okay, start. New approach. See, new approach, start from here. Here. Start here. Now, first step, as I already told, draw tangent at both supports, TA, TB, and mark the slopes at the supports with the direction. Okay, then, already I told you. Extend these tangents at each support to other support. That is, see now, extend the tangent at A till other support. Extend the tangent at B till other support. See this way. So remember now, this is tangent at A. See here, at A. This is tangent at B. Extend. That is TA, that is your TA, tangent at A up to B and tangent at B up to A for this question. If they call A, B, C, A, TA and TC. Okay, now, then mark displacement of each support with respect to tangent at other support. See, tell me, what is this one? Tell me, what is this one? Displacement of which point? Tell me first. This is is it YAB or BA? Very, very important. What I marked there is Y of AB or Y of BA. Displacement of which support with respect to tangent and some other point. It is displacement of A with respect to tangent at B. So very important here, this is Y of A with respect to B. Now, here also, arrow mark upward, okay, because why from here, displacement of B with respect to tangent at A. Full clear? Find these two. First, so, draw with the other support, that is here YBA and YAB as shown. Tangent at A extend, that is Y of B with respect to A, this is Y of A with respect to B. Tangent at B. This much clear? Okay. Now, using second theorem, get these two values. Using second theorem, get these values. No problem. I want to, see, I will not waste time writing how to get, because problem is coming up now. Or I told you, if you write YPQ randomly, displacement of P with respect to tangent at Q is moment of the area of the BM by I diagram between P and Q about what? If I put PQ about which point? If I put YPQ, it is about, moment about. In case I write YPQ, moment about. P. Suppose I write YQP randomly. Moment of the area of the BM by diagram between Q and P about. About Q. That you already know. Right here, if you want, write YBA is moment of the area of the BM by diagram between B and A about B. YAB is moment of the area of BM by diagram between A and B about A. You write that one. Okay, then you write. Now, then apply trigonometry. See now, what you do is you consider, see, one triangle here, light line. There is one triangle here. There is another triangle here. See, here. Now, apply trigonometry and get tangents. See, now, remember, tan theta equal to theta. So, if I mark this theta A, you can tell tan of theta A equal to, see here, when I want tan theta A, this triangle, it is y of B with respect to A divided by the span. Whereas, if I tan theta B, it is displacement of tan theta B, this triangle, y of AB divided by L. Is it fully clear? That's all. See now, these two are already known. Therefore, you get theta A and theta B. These two are already clear. How to get these two? Okay. Now, further steps. How to find slope and support will not come. Why? Already calculated. In the class, sometime I will ask. After all this, when I do the problem, I will first find theta A, theta B. Then, I will not ask maximum slope at that time. In the end, I will ask, find maximum theta and y. I will write, maximum theta is either theta A or theta B, whichever is more. Theta A, theta B, already calculated, use it. Suppose already not calculated, what to do? Students will tell, sir, what to do? Do it now. What? Do it now. If already not calculated, you cannot proceed further. There is no question of, if already not calculated, like when you go to train, ticket first you have to buy. First railway ticket. Bus means you sit in a bus and take ticket. Train not that way. Take the ticket and go. So therefore, wherever they want, ticket is there with you. Okay. Now, if they want slope and deflection anywhere else, it is same procedure as earlier. Right? Then, slope and deflection anywhere they want, same procedure as earlier. But remember, suppose y max required, there is a special treatment there. For maximum deflection, special treatment. I will tell you. See, y max, there is a special treatment or more explanation will be given when the time comes, not now. When the time comes, not now. So what I will do today is, I will take two questions today simultaneously. For both the questions, I will finish everything. Then only pending will be y maximum. Tomorrow for both questions, I will do y maximum. Remember, very, very important. I told you long back, if the load is somewhere here, beam will deflect like this. Y max will be to right of the load. Whereas, if the load is somewhere here, beam will deflect like this. Y max is to left of the load. Suppose some student will ask, sir, if the load is at center, if the load is at center, symmetrical case it is. Okay, sorry sir. Okay. Therefore, this one, special property, you have to locate where theta equal to 0, I will tomorrow's class, before the class, same way, in red color, I will write explanation here and then finish both the questions. Clear? Today, one question load on left side, one question load on right side. Clear now? Clear? Tomorrow same will be continued. You should do one thing. When you finish first question, You do not make fair copy today. Why? Halfway through. You wait for one day. So, tomorrow, after tomorrow's class over, make fair copy of both the questions. Clear? If clear, tell me. I will rub the full board and start now. If clear, I will rub the full board and start. Okay. 1 minute. Just wait a minute. Full explain now. Nothing is there. And one more note required. I don't require it. See, when you draw bending moment diagram, when it was symmetrical, so far you wrote due to symmetry, VA equal to VB equal to total load by 2. That you cannot write here. You have to take sigma M and sigma V0 and get the what? And get the reactions. Okay, start. Now, question number 1 I will write here. And question number 2 I will write here. See, question 1, dictating. A simply supported beam, black color. A simply supported beam of span, any span will do. Any span, okay. I will take span of 12 meter. 12 meter is loaded by a concentrated load of, I am taking a load which is a multiple of 3 and also multiple of 9. There is a reason. If I take a load multiple of 3, reaction will come round number. If I take multiple of 9, slope and deflection also comes round number. Just to eliminate what? That 31.48675, just to eliminate. Multiple of 3 and 9 I want. A load of 90 kilonewton. Okay. Not center. At this is 12 meter, center is 6 meter at 4 meter from left hand. First question, 4 meter from left hand. See. Second question, a simply supported beam of span 15 meter is loaded by a point load of 90, double martini, 180 kilonewton. I want a multiple of what? I want a multiple of span, I want multiple of 3, load I want double multiple of 3, so that children can be eliminated. I will tell at 5 meter from right hand. I will call A, B. You should make fair copy of both questions separately. This is C, this is C. Okay, now, both the questions, question is find 1. Slope and deflection under the load. Under the load. That is at C. That is both the question theta C and YC. And also second one, maximum slope and other one maximum deflection. Is a question. This is the important. This will come today only. Now, correctly make fair copy. Start. Question number 1 start. See, make a note. We want to draw bending moment diagram. So, you cannot write VA equal to VB equal to total load by 2. You cannot write. So, question 1, find reaction. First what? First find reactions. Find reactions. Okay. Question 1 and question 2. For both questions, apply sigma M about A0 and sigma V0. If anybody cannot find the reactions, better not come to the class. Tell the answer. If I take moment here, minus VB into 12 plus 90 into 4 equal to 0. So when you make sigma M 0, you will get VB equal to, here also VB equal to, answer. First question VB. 90 into 4 divided by 12, VB equal to 30 kilonewton. Okay. VB equal to 30 plus 30 kilonewton. Second question, minus VB into 15 plus 180 into 10 equal to 0. VB equal to, that is a 2:3 ratio. 1:3 means 90 VB 30 ಇರಿ ಹೌದು ಒಂದು ಬೋತ್ ಆರ್ 1:3 ರೇಷಿಯೋ. ದ್ಯಾಟ್ ಇಸ್ ದ ಅಡ್ವಾಂಟೇಜ್. 1 minute, okay, I can change it. ಇರಲಿ ಬಿಡಿ ಪರವಾಗಿಲ್ಲ. ದಟ್ ಪಾಯಿಂಟ್ ಲೋಡ್ ಪಾಯಿಂಟ್ ಇನ್ ಬೋತ್ ದ ಕೇಸಸ್ ಆರ್ 1:3 ರೇಷಿಯೋ. ಓಕೆ, ನೋ ಪ್ರಾಬ್ಲಮ್. I will change the question. Or 1 minute. Second question, I will make 6 meter from here. By I do not want same pattern. Here 1/3, there also 1/3. Change it. Tell the answer. Second question. Load 180 at 6 from right hand. VB. 180 into how much? 9 divided by 15. VB. 180 into 9 divided by 15. 108. No, change. I change the distance. Instead of 5 meter, I take a 6 meter. 108. Okay. VB is 108 kilonewton. You solve separately. Plus sigma V0 will give you here VA, here also VA. 90 is there. Plus 60 kilonewton. Here plus 108 andre I think 72 kilonewton. Correct answer, tell me. Both are correct. Here 60, there 72. Both are correct. Both are correct or not? Okay. Now I will continue question number 1. After it reaches the stage of y maximum, I will stop the question and go to second question. But second question, little work I will give for you. Okay, start. Now I write here. Question 1 continued. Question 1 continued. See correctly. Draw the beam neatly, as neat as possible. Is the board fully visible? Tell me. Is the board fully visible? Any problem? Board visible? Okay. Now, see, AB. This is A, this is B. 9, this is 12 meter 6 here. There is a point load of 90 kilonewton. 90 kilonewton at 4 meter from here. This is 4 meter. If that is 4 meter, this will become 8 meter. Okay. A, B, C. This reaction VB equal to, will you answer VB? First question again, 30 kilonewton. Reaction VA equal to 60 kilonewton. When I start the question tomorrow, these all will come once again. Same diagram you are using, I will draw before the class. Okay, now draw bending moment diagram. This is the bending moment diagram. Kilonewton meter value, sagging positive. You should write bending moment at A equal to 0 equal to bending moment at B. See, at A, look this side, 0, at B, that side. Bending moment at C equal to, look this side, 60 into 4 plus 60 into 4 equal to plus 240 kN meter. Or if you look that side, 30 into 8. I usually ask the question in the class. Even MTech people or even those who finish PhD, they will fall to the trap if they are newcomers. I will tell them, see, if you look this side, it is clockwise positive, but if you look that side, it is anti-clockwise. Therefore, they will tell negative. I think you will not tell, correct? Clockwise, anti-clockwise is not to be told. Both are sagging. This I will not explain today. 240. So, your ordinate here is 240. See, available space at use here. This is 4 meter. This is 8 meter. Okay, bending moment diagram, all are in kN meter. See, this way. Now, this is the bending moment diagram. See, in the bending moment diagram, this distance is 4, that is 6, 8. You can already see there. So, therefore, right, to save the time, 4 meter, 8 meter. If you want to, this is the point A, this is the point B, this is the point C. If I want this length 4 meter, this length 8, I want right here. Now, leave some space. Anybody can tell me why leave some space? Here, tell me why leave some space here. Anybody can tell? Why leave some space there? No, leave some space. Reason. Think a little. Leave some space. Get any idea? I tell no idea. If no idea, tell no idea. Some space required. So that when you read later, no confusion. I will tell you, you are not telling. Space because later you are marking some maximum deflection. There are some x will come. If you write elastic curve right here, later it will become overlapped. So leave some space. Okay, then draw dotted line, the initial position. Remember, dotted line is initial position. Draw elastic curve. Remember, elastic curve is always smooth curve. Tell me, when the beam bends this way, elastic curve, there will be more deflection to right up load or left up load. How much not required? There will be more deflection to right up load. See, beam will bend smoothly like this. You see, wherever you apply the load, even if you apply load here also, see bending, see, bending will be like this. Where? More bending. To right. Second question, when you apply load here, see, more deflection will come this side. Okay, now start. Draw elastic curve as smooth as possible. Okay, over. Now, this is the final position A, final position B. Correct? Okay, now, C point will shift here. C will shift here. This is the point C. Okay, that's all. Now, if you want later, this is your deflection at C later. Okay, now, draw tangent at B. See, it will come and extend it up to other side. See, here space problem is there. I slightly turn inside. Oh, if I go straight here, it will come beyond the board. So, I'll do one thing. I'll make slightly this way. Okay. Tangent at B, extend it up to here. Remember, this is tangent at B, this also tangent at B. Then, draw tangent at A. This is tangent at A, this also tangent at A. I told you, find what is this value. This is displacement of B with respect to tangent at A, y of B with respect to A, and this is displacement y of the point. This is displacement of the y of the point A with respect to B. Now, first to find what? To get theta A and theta B. To get theta A and theta, right here first. First step is always to find slopes at supports. Slopes at supports. Supports. That is to get theta A and theta B. To get theta A and theta B, to get them, what? Get y of each support with respect to tangent at other support. Other support. Okay, start. That is y of A with respect to tangent at B. See, A is important. And y of B is important point is B. B is the red color. Okay, I will put one thing. B I will put red color. Here, A is the red color. Okay, black color. Okay, just to understand, I use red color for the first point. Y of A with respect to tangent at B and y of B with respect to tangent at A. Start. To get y of A with respect to tangent at B, right here. That is, you write displacement of, next time not writing, displacement of our point A with respect to tangent at B. Apply Moore's second theorem, not first theorem, second theorem. So, therefore, y of A with respect to B is moment of the area, see mechanically, moment of area of BM by EI diagram. You can tell half sleeping, BM by EI diagram, then get up. Between your point A and B, very important, about which point? About A. Moment about A, be careful, equal to, see here, two triangles are there. If you take both the triangles together, CG will not be known. Actually, there is a formula for CG, L plus A by 3 and L plus B by 3, when you combine these two. But what happens is, people get confusion. No, simple way. What you do? This triangle and this triangle take separate. Start. This area, half into 4 into 240. 240 is this area. Moment about A, its CG is here, into 2 by 3 of 4. Why 2 by 3? This area CG is here. Okay. Plus, once again, I will put equal here. Half into 8 into 240 is the area, into this triangle CG will be here. I want moment about A. It is 4 outside. 4 plus another from here to here is 1/3 of 8. Close the bracket. Divide by EI. Anybody can tell me what is correctly YAB? Fast. By that time, I will do one thing. I will tell the answer for the question. See, for this question, you do whatever you want. How much theta A should come, how much theta B should come, how much theta C should come. I will remove, I'll write somewhere here where space is there, so that no confusion. Okay. Somewhere I'll write, or I'll write here. How much theta A should come, how much theta B should come, how much theta under load should come, how much YC should come, where is Y maximum, and how much is Y maximum. Okay, you get the answer. Answer. 7680 by EI equal to 7680 by EI. Okay, now next point. Again, now find y of A, y of B with respect to A by using once again second theorem, right? Y of B with respect to A is moment of area of BM by EI diagram between B and A, about which point? About B, equal to, I'll write here, first this area, now moment about B point, half into 4 into 240, half into 4 into 240 is the first area. Remember, moment about B is 8 meter plus from here to here is 1/3 of 4 plus one more, half into 8 into 240 area into, from here to here is 2/3 of 8. 2/3 of 8, answer divided by EI. Tell me this answer also something by EI. By that time, I will do something. Whatever you do, your theta B has to come 640 by EI. Your theta A should come 800 by EI, whatever you do, and your theta C should come 320 by EI, your deflection at center should come 2560 by EI, 2560 by EI, and your Y max should come at 6.53 meter from B, and that Y max will be equal to 3832.09 by EI. Most probably correct. You never worry how the answer came. Oh, no, wrong. 6.53 is correct. Because I took wrong slope. 2786.975 by EI. You make this note. When the time comes, tell me answer tallies or not. See, just for information. I took this much time because I took wrong slope. By mistake, order was interchanged. But to get all this, it takes around half minute. How? Nothing special. Mix all the methods. So there, but anyway, when you learn each method. Okay, now start, continue. Don't worry about these things. Now I will rub this one now so that I can go to further step now. Okay, this all I will rub. So you know the value of which one? You know the value of YAB and YBA. Tell the answer. Your YAB came how much? 7680 by EI. Your YBA came. You are not told the answer. 9600 by EI. Okay, thank you. 9600 by EI you got. By EI. Okay, now I will remove everything now. Start new part now. See, start. Now, I told you, now apply trigonometry. One trigonometry is, see, this triangle. Other trigonometry is this triangle. One trigonometry is this triangle, other trigonometry is this triangle. So I forgot to mark here. This is your theta A, this is your theta B. Okay. Now tell me, first answer. Now from trigonometry, you write here, tan of theta A. Be careful. When you want tan of theta A, it is this side, not this displacement. See, tan theta A equal to y of B with respect to A divided by 12. YBA, you already got 9600 by 12. And you take tan theta equal to theta A. Therefore, tell the value of theta A first. 9600 by EI by 12. 9600 by EI by 12. Answer. slope theta A first. Using trigonometry, you get theta A now. It took back to divide by 8 divided by 12. 800 by EI. Theta A is 800 by EI radian clockwise. Okay, thank you. Over. Now, use other trigonometry. See here. Use this triangle. Same way, tan of theta B equal to theta B equal to, see here. Tan theta B means this triangle. Y of A with respect to B. A is important. Interchange is gone case. Divide by 12. Y of A with respect to B, you got 7680 by EI. Tell the answer. Therefore, tell the value of theta B. Theta B. To theta B. Theta B. 640 by EI. See, before you apply the BEI radian, it is anti-clockwise direction. Okay, see. Before I started all this, where's the pen cap? Oh, 1 minute now. I lost the cap for the pen. If I leave as it is for long, it is here. Got it. Pen will not write later. Okay, start. Now, see, I told what theta A should come, what theta B should come. It came. It will come. Now remember now, you know the value of theta A and theta B. I write here. Theta A is, this all I remove now. So, now you know the value of theta A equal to 800 by EI. You know the value of theta B 640 by EI. Therefore, maximum slope is over. Why? You know that later, not now. Maximum slope is slope at A or slope at B, whichever is more. For our question, maximum slope is 800 by EI at A. Next question, it will become at B. Okay, over. Now, second question. If I start in the class, can you get up to here? Tell me. Second question. If I start in the class, sketches I will give you. Can you get this much? Can you get this much for second question? First. Here or today only, not later. Today only in the class. If I do this much, if I write the sketches solve. Second question. Yes, okay. Later, not now. Now see, one by one. Slope. Now, what they want in the question? See, next, to find to find what? Slope and deflection under load, that is at C. Okay, do one thing. Come here. At C, mark tangent. This is already known for you. Tangent at C. See, if I draw horizontal line here, this is your theta C. Now, mark theta C. Okay, then apply the first theorem. Remember, now tell me, from A to C or B to C? Anywhere will do. From A to C or B to C? Tell which is better for you. C point is somewhere, C elastic curve. From A to C or B to C? See that sketch there. Which side nearby? From A to C or B to C? See there. Our point is somewhere here. A to C. Next question, B to C, I will tell you. Okay, start. If you apply first theorem, consider the points A and C. Then, this already I told you earlier. For symmetry or unsymmetry, if any point you want slope, consider that side support and that point. Okay. Then, theta A minus theta C equal to area of BM by EI diagram between A and C equal to A and C, one triangle, half into 4 into 240 divided by EI. Now, you know theta A is already known. Substitute theta A 800 by EI minus theta C equal to that answer Half into 4 into 240. What is the answer? Half into 4 into 240. Fast, fast. Half into 4 into 240. Answer. Little fast I would give. I want to finish both the questions so that tomorrow we can do Y maximum. Because Y maximum, full board I will explain. I want full board to explain Y maximum. Important concept. Bega, bega. To this much, 480 by EI. Oh, 24 ಆಯ್ತು ಬಿಡಿ. 480 by EI. Therefore, slope at C equal to 800 minus 480. Theta C will go that side. Tell the answer. Slope at C will come something by EI radians. See the direction? It is clockwise direction. Answer. From 800, subtract 480. From 800, subtract 480. 320 by EI. 320 by EI radian. Oh, my next answer also is correct. Correct? Okay, now I will remove this one now. Now I will find what? See, tomorrow's class, when I want Y maximum, I will tell you theta A, theta B are known. You should tell the answer at that time. Okay. Now I will find lastly deflection at C. Deflection at C, that is YC. See, mark YC. Mark YC. Note, direct YC will not come. YC will not come. Find Y of C with respect to tangent at some other support. See, find Y, this is this side, Y of CA. See, I told you earlier, first of all, I am wasting my time. If you want YC, I am sitting here, you find this distance. What is one? This is Y of C with respect to tangent at A. Find YCA. This question YCA. Next question find YCB. Clear? This question YCA. Next question find YCB. Clear or not? I will explain the question. Clear? Okay, now start. Now apply second theorem. Second theorem. Then YCA equal to moment of the area of BM by EI diagram between C and A. Very important about C equal to half into 4 into 240. Half into 4 into 240 into moment about C. This distance is 1/3 of 4 divided by EI. Tell me fast this answer. Half into 4 into 240 into 1/3 of 4. You tell this answer. Last but one calculation for today. I will not bother you too much then. That answer. Half into 4 into 240 into 1/3 of 4. Fast, fast. Don't waste time. Because I got another class. I want to gain this time because for FPM class, some statements in the board I have tried before the class. 640, the higher value 640, yellow is the 640. 640, yeah, I thought. 640 by EI. That is this distance. Now, apply trigonometry for this triangle. Then we have tan theta A equal to, see here, YC plus YC plus YCA. Our requirement is what? We want to find YC. See, YC is more important to us. Our important is YC divided by 4. And you take tan theta equal to theta. So tan theta A equal to theta A. Therefore, theta A, 800 by EI equal to deflection at C plus YCA is 640 by EI divided by 4. Therefore, you get deflection at C something divided by EI meter down. Start. 800 into 4 minus 640. Answer. To last calculation I am asking you today. 800 into 4 minus 640 will give YC. Last answer I am asking today. 2560 by EI. 2560 by EI. I told long back, see there, it is still there. So all the value given by me, correct or wrong? Why note down these two? Tomorrow you require, I won't remember. Or tomorrow I can do once again. What is there? Half minute. But still, if you tell me tomorrow, same answer, thank you very much. Okay. Okay, now I will stop the first question. See, now next question is what? I'll write here only now. See, next part. Next part is to find theta max and y max. Second part, y max. Right, first, theta max equal to theta at support. Theta max will be always theta at supports. Therefore, theta max equal to either theta A or theta B, whichever is more, whichever is higher. These two are already both these are already calculated. Theta A you got 800 by EI, already there. Theta B you got 640 by EI. Therefore, your theta max equal to 800 by EI radian in this question, that is at left support. Next question, it will become right support. Theta max clear? Next step is the most important, red color writing. Next is y maximum. Y maximum tomorrow. Agreed? Shall I start the second question and correctly bring it up to here? I will give work for you. You should do something. Shall I start second question and explain everything and take a small break? Shall I start second question, bring up to a level and stop? So tomorrow, both questions, I will do y maximum. Agreed? Okay, start. Now, see, how much I explain now, correctly understand and make a note. This all I will remove. Remember, these two values, remember tomorrow. Or I will do once again. What is there? See, now, second question. First, question 2. Y max is pending tomorrow. Now I will start question 2. First, to mark the beam. Little high speed. Mark the beam. This is A, this is B. Load is, that is 6 and 15. 7, here, somewhere here. Here is the load. What load is 180 kilonewton. This is A, B, C. This is 6 meter. This is 9 meter. This reaction VA, we got 72 kilonewton. Reaction VB, we got 108 kilonewton. Draw bending moment diagram. 0 here, you should write everything. 0 here bending moment is either 72 into 9 or 108 into 6. Tell the answer. Any side you can see. This is 9 meter, remember. This is 6 meter. Either 72 into 9 or 108 into 6. Anything will do. Answer. Bega. Either 648. Don't give wrong answer. If you give wrong answer, my answer will correct 648. Okay. Leave some space. Draw elastic curve. This is A, this is B, this is C in the original position. Elastic curve. This is B, this is A. Then later, see, somewhere here is maximum. Scale barbeki. This side, little more bending. Okay. Now okay. See. Now this is the C point will come here. Y max is here. That will come tomorrow. See. Now draw tangent at B. I should have space problem here. I look. Okay. This is tangent at B. This is point C. A C. Akadog C. This is tangent at B. And this slope is theta B. This is tangent at A. Go there. Tangent at A. tangent at A. Find displacement of B with respect to A. Find displacement of A, y of A, y is black, okay, y of A with respect to B. This is your theta A. Okay, now the way I did it, find every statement same. First you write systematically, you solve the question systematically. Here rough calculation, why homework it is. Write all the statement I gave you last time, everything right. First is find theta A and theta B. For that one, first you find y of A, y of A with respect to B. You find moment of the area of the BM by A diagram between A and B, moment about A, you should get it. Then find y of B with respect to A. You should find statement just now given. Someone will tell, sir, it's already removed. After the class is over tomorrow, write fair copy, then write moment of the area of the BM by A diagram between B and A about B. Happily get these two values by EI. Then apply trigonometry. Apply trigonometry. See, tan theta A actually equal to theta A equal to YBA by 15. Full span is 15. Therefore, you get the value of theta A. And tan theta B equal to y of A with respect to B by 15. Therefore, you get the value of theta B. We get the value of theta A, theta B. Okay. Something by EI, something by EI. This will be clockwise, this will be anti-clockwise. Then, find what? Slope and deflection at C. ನೋಡಿ, mark theta C. ನೋಡಿ, light line here. ಇರೋ ಜಾಗದಲ್ಲಿ adjust it. Okay. Theta C. To find theta C, apply the first theorem. See, use it this side. Oh, point shift ಆಗಬೇಕಾಗಿತ್ತು. Oh, see, this point should have come little this side. Okay. See, ಇಲ್ಲಿದೆ see. Okay, no problem. Theta C. Apply the first theorem. See, elastic curve is this side now. Apply the first theorem from B to C. Then theta B minus theta C equal to area of the BM by A diagram between B and C. This triangle, theta B is already known. Get the value of theta C. Okay. Something by EI, radian will come. It will come anti-clockwise now. Okay, then lastly, to find deflection at C, directly not possible. You find deflection at C, red color I will write, YC. Only today, red color. This is C. This YC required, red color. Tomorrow Y maximum. What you do is, find the small distance. What is one? Y of the point C with respect to tangent at B. Find y of C with respect to tangent at B using second theorem. Moment of the area of the BM by A diagram between C and B about C. Get that answer. YCB comes. Once you get YCB, apply trigonometry for this full triangle. Then tan theta B equal to what? YC plus YCB divided by 6. YC you require. Tan theta equal to theta B. Theta B known. YCB just now known. 6 is there in every calculator. Therefore, get the deflection at C, something divided by EI. Lastly, write theta maximum is either theta A or theta B. This time, theta B will come more. Therefore, your theta max this time will be theta B. Write whatever you got. Y maximum tomorrow. Y maximum ಕನ್ನಡದಲ್ಲಿ ನಾಳೆ, ಹಿಂದಿಯಲ್ಲಿ ಕಲ್, ಇಂಗ್ಲಿಷಲ್ಲಿ tomorrow. Over. Okay. Now, 8:45, I will give 5 minutes time. Can you get all these values? Shall I give the answer? Shall I give the answer and wait for 5 minutes? First, tell me. Shall I give answer and you make fair copy? Not now. After tomorrow's class, when both the recordings are available for you, you consider first question, complete up to y maximum, then start second question. Okay, I will give the answer now. Answer is not a problem. Tell the reaction. This reaction is how much? This is 108. This is 72. Saku. Sometimes people wonder what is doing there. Your theta A will come, theta A, 2268 by EI. Theta B. Theta B will come 2592 by EI. This is theta A, my answer. This is 2592. Theta B, my answer. Slope at C will come 648 by EI. And deflection center will come 11664 by EI meter down. And tomorrow's class, ivattalla, for tomorrow's class, advance booking. Advance booking for tomorrow's class. Okay. Advance booking for tomorrow's class. Your Y max will come at 7.725 meter from A, and you will get that Y max value tomorrow equal to 1,001.128 by EI. I think, see, 12001, 1 rupee jasti, 0.128 by EI. Tomorrow you will get it. So tomorrow you should tell this is correct or not. I will solve it tomorrow. Advance booking. See how much time it took all together. Say within a minute. Which one? Theta A, theta B, theta C, YC. Where is Y maximum? How much is Y maximum? These tricks can be learned, as I told earlier, not by crude method. If you know correct concept of each and everything. Okay. Shall I wait for 5 minutes? I wait for 5 minutes now. You tell me, you type got all the values or type one by one. Got theta A, got theta B, got theta C, got YC. You can type that way. So I will not come back once again here. I will wait for another 5 minutes. At least I want at least 1 or 2% to comment what? Comment that got at least thetas. Okay. I will not come back here once again. I will make ready for next class. I will wait for 5 minutes. At least for 5 minutes you type answer. After 5 minutes, I will come and announce and close the class. Make fair copy of both the question tomorrow when I finish everything. Okay. Thank you. Okay, nobody commented that got the answer. Nobody commented. At least I will get little happy if I tell that. See, when you respond and tell answer came, that gives you not confidence to me. There is no question of my confidence. My confidence will be there. See, sometimes people will tell, get the answer, I will get more confidence. What more confidence? I get more encouragement or motivation. See, so many people came today. Nowadays, I observed live class, the strength after the class when I view, I finding 400, 500s. Recently, from past 1 week, each live class, sometimes it goes up to one day 900. That is, so many people are watching, but they will come, see sometime and go. They don't participate. I don't understand what is their problem. Participate, and when I ask question, answer. That is how you learn. Even I tell you, correctly participate and communicate. You give your version. If something is not clear, ask me. If it is connected with the subject, I will answer immediately. I will never tell you tomorrow, day after tomorrow like that. Sometime I tell you, concept I will tell later, tricks I will tell later. If you ask something is not clear, suppose you tell, why moment about B not clear, I can tell immediately. Even then people are not responding. They will just simply, what is there? Their name will come. Some are afraid. If their name comes, what is there? You ask, yesterday someone asked a doubt. I told unconnected question. Long back someone commented some other way. He told something else he asked. I told not this subject. He writes a question RCC in the BSK class. I told immediately. I know that person always is like that. I have seen him earlier. I told unconnected question. I don't answer. And you are not regular to my class. But one thing, you should study all the cases. Now see, in strength of material, still conjugate beam method is there. Very powerful method. Then some little strain energy part also I will tell here. Then columns. That much I will do in YouTube. When I go to indeterminate structure, I will do in Zoom only. I will stop this one. Okay. Now, do you want two homeworks same way? Two homework, one load on right side, one load on left side. Do you want homework? Me tell me with the answer. Or shall I give tomorrow at the end of the class? Because tomorrow, Y max will be over, not much time. If I start at 7:30, 7:35 like that, by 8:30, 8:35, Y max will be over. So I will leave the class a little earlier because I got a PM class. Some writing is there. But that done, shall I give one more extra question where load is this side, one more extra question where load is that side with all the answer? Shall I give tomorrow? Okay, I can give now, but already 8:56. I have to prepare. Prepare means what? Make the board ready and write some sketches now. Okay, shall I close? If you got all the values, good. That is appreciable. Shall I close now? Okay. See, in the FPM class today, I have sent, it's a public class. I am doing analysis of pin-jointed frames by finite element method. It is a very important concept. Of course, big frame you cannot do. You can do simple frames of this type, pin-jointed frames. This one, how to find force members, that I am taking. Those who are serious here, you can attend that one. At least some knowledge. Your choice. Okay, thank you. I will close the class. Tomorrow I will finish Y max for both the question. Okay.